This is actually from yesterday's. This is from yesterday's. We have 2 sine of 165, cosine of 165. This looks very familiar, very similar to a problem that we did yesterday, a formula that we used yesterday. Share with the person next to you, what does that look similar to that we looked at yesterday? Go, talk, 20 seconds.
Yes. I watched the video. My eye has been twitching all day.
5, 4, 3, 2, 1. It turns out that this is a double angle formula, isn't it? Okay, so this is the same as sine of twice 165. What is twice 165? 2 times 165. 330 degrees. What is the exact value of sine of 330? Figure that out with the person next to you. Go, what's the exact value of sine of 330? Everybody should be on the ball here.
Square root of 3 over 2.
So the sine.
Yes.
Yeah.
Yes.
The coordinate for negative or for 330 is root of 3 over 2 and negative 1/2. Sine is the y value, so this is 8 negative 1/2. So this expression simplifies to negative 1/2. Sometimes it simplifies to nice numbers, sometimes it doesn't. For example, if you had sine of, say, 310 degrees, that doesn't come out to anything special, so you just leave the sine of 310. Look at the next one, cosine squared minus sine squared. Does that look like something familiar from yesterday? Yeah. It turns out that this is equal to the same thing as cosine of twice an angle. Okay. So knowing those formulas back and forth, that's just part of what you're asked to do. So on your assignment from yesterday, that'll be problems 4 through 7. 4 through 7, you'd be probably more comfortable doing those right now. Okay. So, all right. So the piece that we want to look at today is our lowering powers formulas. And you don't have to write this down. I'm just going to help you understand what it is that we are going to do. Yesterday, you saw this piece. You saw that cosine of 2x was equal to 1 minus 2 sine squared of x. And you saw cosine of 2x was equal to 2 cosine squared of x minus 1. Those were 2 formulas that we saw. Bea, you said you watched the video last night?
Yep.
Okay, and those 2 formulas written on there along with the third one that we just looked at. What I want to do today is all I want to do is I want to solve for sine squared. So I'm going to subtract the 1 over. You don't have to write this down, just follow along. You get cosine of 2x minus 1 and is then equal to negative 2 sine squared. Now I'm going to divide by negative 2, and when I do, the negative switch to positive there, so I get a 1, and then I get a minus cosine of 2x all over 2 is equal to sine squared. So this is a new formula. And what it does is it allows me to take something that's squared and write it without a squared. You might say, why would we ever want to do that? Well, the truth is, as we said, the class is pre-calculus, so we're preparing you for calculus. If you were given that type of a problem in calculus, you'd be like, I've got no clue. If you're given this type of problem in calculus, you'd say, hey, I at least have a fighting chance. Okay? This problem I can do no issues at all. I have no idea how to do that. Okay? So these substitutions are important. We could solve the same thing over there, but let's just write down the formulas and then get to the examples. And the formulas are as follows. Lowering powers. If you have a sine squared of x, by the formula I just derived, you can rewrite that as 1 minus cosine of a double angle divided by 2. And that's useful for us, primarily in Calculus 2 and Calculus 3. Not so much Calculus 1. Calculus 1 is still very introductory in that fashion. Cosine squared of x is equal to 1 plus the cosine of 2x, all divided by 2. So pretty similar, aren't they? Very similar. And then finally, the last one, tangent. We do tangent squared of x. And that would be equal to sine divided by cosine, which is going to be 1 minus cosine of 2x divided by 1 plus cosine of 2x. Please make sure you grab this sheet of formulas that you have, and look where these are. On your sheet, they're called power reducing formulas. So if you can find those formulas, make sure you know where they are, because that's what you're going to use on the test. Everybody see where they're located? Okay, that's the spot you want to reference. So the bad news is this is not easy to do, but the good news is that we're going to do 2 examples in class. On your assignment, you only have 3 examples, and 2 of them we've already done, so you should be familiar with them. And then on the test, I will give you 1 of the 3 problems from your homework. Okay? So we could go bonkers on this section, do all sorts of complicated stuff, but you really don't use it that much moving forward. If you could just simply reduce the 3 problems in your homework, you should be fine. We'll show you 2 here. That way when you get to your homework, you can, if you get stuck, you can just follow along with what we did in our notes and go from there. So notice the directions. The directions say to rewrite the following expressions in terms of first power of cosine. So I do not want a squared and I do not want a sine. I need to get rid of any squareds. I need to get rid of any sine. So what I'm going to do is I'm going to substitute something in for sine squared. That substitution will be my formula, 1 minus the cosine of 2x divided by 2. And for cosine squared, I'm going to substitute 1 plus the cosine of 2x divided by 2. What do you notice about those 2 expressions? They are conjugates. So when we multiply those conjugates in the numerator, what's going to happen? The middles will cancel. Good. So we multiply these conjugates, and we get 1 times 1 is 1. As you said, the middles will cancel, and then you get negative cosine of 2x times positive cosine of 2x. And that will give you negative cosine squared of 2x. Multiply the denominators, and you get 4. Now, I'm guessing that a number of people maybe wanted to take that 2x times that 2x and get a 4x squared. I just want to be clear, if you had sine of x plus sine of x, that does not then become 2 sine of 2x, does it? We just say it's 2 sine of x. Or if we did cosine of x times cosine of x, we wrote that as cosine squared of x. We did not write that as cosine squared of x squared. It's not like we took the x's and multiplied them together, did we? So you don't do anything to the angle. You just do it to the operation. Okay? All right, look and see what we've accomplished. We have everything written in terms of cosine. Check mark. Got that part done. But is it to the first power? No, it's not. So we're going to have to put in a second formula, another power reducing formula. Do we have a power reducing formula for cosine squared? Yeah, but we have a slight issue. Our power reducing formula is for x, whereas here we have 2x. So this is the one slightly complicated thing you have to think through, and then the rest will be just fine. I'm going to create a new formula. You might be like, well, how do you just make up a new formula? You guys are going to be able to help me. It's not going to be any big deal. I have cosine squared of 2x is equal to, and let's look at what happens as we go from this formula to this formula. What happens to the angle as we go from here to here? It doubles. So I can write a new formula. This one, I just have to double the angle when I get to that spot. So it's still a 1, it's still plus, it's still cosine, but instead of 2x, it's going to be 4x. So all we have to do is double that angle. So as I go to this piece right here, I have a 1 minus, and we said it was 1 plus the cosine of 4x over 2, and that all sits over 4. I now have the problem of a complex fraction. I'm going to simplify that by finding common denominators. I'll rewrite this as 2 over 2. And look and see what we can combine. I have a 2 minus 1. That will give me 1. And then I have to distribute the subtraction sign all the way through. So it's not going to be a plus cosine of 4x. It's going to be a minus cosine of 4x. What is my new denominator in the numerator? My new denominator is 2. And that all sits over 4 over 1. I'm almost done simplifying my complex fraction. Now I just have to multiply by the reciprocal, and we're going to get 1 minus the cosine of 4x all over 8 when you multiply by that reciprocal. Not easy, but doable. And like I said, we'll expose you to the 3 problems that you're going to need to be able to do possibly for the test, and that will be that. All right, last one. This one is different. It is just cos or sine to the 4th power. Notice I don't have a substitution for sine to the 4th power. I only have a substitution for sine squared. Any ideas on where I should start?
Sine squared plus sine squared.
Excellent. Sine squared of x times sine squared of x. So I rewrite it in terms of a squared, then I substitute. My substitution is 1 minus cosine of 2x over 2 times 1 minus cosine of 2x over 2. So on the test, this problem would be worth 4 points. At this point, I could give you 1 point. Okay? All right? Now, I multiply. They are not conjugates, so I'm going to have something in the middle. 1 times 1 is 1. Anybody know what I'm going to get in the middle? Yeah, a negative 2 cosine of 2x. And then I have a negative cosine times a negative cosine is a positive cosine squared of 2x. And that all sits over 2. If you get to that spot, I can give you a 2nd point on the test.
Over 2 or over 4?
Over 4, thank you. So then you get 1.5, I guess. Now we continue. We're going to make our substitution. Instead of cosine squared of 2x, do you remember what I put in the place of that? Yeah, you double that angle and you get 1 plus the cosine of 4x over 2, and that all sits over 4. I could give you a 3rd point for getting there. And to get the 4th point, I must simplify my complex fraction, meaning I need to have common denominators. So 1 I'll rewrite as 2 over 2. The 2 cosine of 2x I'll rewrite as 4 cosine of 2x over 2. And then 1 plus cosine of 4x over 2. All over 4. What are the like terms that you can add together?
2 and 1.
Yep, the 2 and the 1 make 3. And that ends up being the only like term you can add together. Cosine of 2x and cosine of 4x are different. So it's just minus 4 cosine of 2x plus the cosine of 4x. The new denominator is 2, and those all sit over 4 over 1. My last step is to multiply by my reciprocal. And as you multiply by that reciprocal, we get 3 minus 4 cosine of 2x plus cosine of 4x. And this will be all over 8. And that, my friends, is your result. Not too bad. Two of the problems in your homework will look identical to that. Please take out your homework. I see Haley's work right here, problem 8 and problem 10. Those are exactly like we just did, so try them on your own. And if you get stuck, you can obviously look at your notes. Problem number 9 is slightly different. It's a cosine to the fourth. Number 11 is optional. The fun factor is very high. So if you want to engage in that, go ahead and give it a shot. Might kind of tease your brain a little bit. Gina likes my jokes. Thank you, Gina. As far as the answer keys are concerned, you can see that 7.3, I have the answers right up here for the front side of that from yesterday. And then I have the back side up here all ready to go for you as well. So if you need help on something, I can help you. You've got a good almost 20 minutes here, actually more than 20 minutes. Go ahead and get rolling. You can probably get something done.